Hello everybody, welcome back to another Gregorius Maths video. Today is my first improvised session and I will be using the chain rule 4 times. This one is for you, Prfkt Black. Okay, what will I actually be doing? I'll be doing the derivative of this funny notation. This x to the tetracration of 4, I think that's how you say it. This basically means that so x to the power of x to the power of x to the power of x, so there's 4 x's, okay, which equals d dx of e to the x to the x to the x ln x, okay, because we can write this x here as e to the ln x, and then that to the power of x dx, and then you can multiply the powers. So we do obtain this. And now, here's where the chain rule comes into play. This equals d dx of... This equals... Okay, so the chain rule says we have to do d dx f of g equals f prime of g times g prime. So what this means, don't click off the video, what this means is that we differentiate the outside and then with the input. Okay, I'm going to make it all sound too confusing, so I'll just do this and hopefully you'll see. So this equals, the derivative of e to the x is just e to the x. So the derivative of the outside function is e to the x times ln x. But we're not done. We have to multiply by the derivative of the inside, which is the inside function is just this function here, which is a product of two functions. So we have to use the product rule as well. In fact, I'm going to put brackets here. Hopefully it's going to go. So f is just x to the x to the x times g prime is just 1 over x plus g ln x times, we have to do the derivative d dx of x to the x to the x equals d dx of e to the x to the x ln x, which equals, again, same process, the derivative of the outside function is just e to the x times ln x, but then times the derivative of the inside function, which is x to the x times 1 over x, which is g prime, plus ln x times, now what's the derivative of x to the x? This is not so bad because now we can actually do this. D dx of x to the x equals d dx of e to the x ln x. Chain rule again. This equals e to the x ln x, because this is the outside function, times the derivative of the inside, which is f, times g prime plus g times f prime, which equals x to the x times that and that equals 1 plus ln x times 1 is just ln x, which equals x to the x. I'll just leave it like that. Okay. And now, this means we know the derivative of that. We can plug this in here. Times x to the x 1 plus ln x. Okay. And now we're nearly done. We just need to simplify this. This equals, that is just, to save space I'll write it in this notation, times Actually, I'll distribute this. So x to the x times ln x. So, because we see this and that is a common factor, we can factor it out. Times that, and our brackets. 1 over x plus, well, if you think about it, this ln x times this ln x becomes ln x squared. Okay? And now that we know this, we can use this information. We can use this information to finally obtain our answer. So, all we need to do is plug this in and simplify. So, times. Just to be consistent, I'll write it in this notation. X to the x to the x times x to the x times 1 over x plus ln x squared. Yeah, okay. One more bracket though, okay. And now, I'll write the answer out in back. Answer. Answer. Equals. This part here is just x. To save space, write it out like this. And now we see that is a common factor times x. Now, we open the brackets. 1 over x plus ln x times x to this 2 power thing here. Now times 1 over x plus ln x squared. Okay, so just to do it one more time nicely, I'll write it here. Times 1 over x plus ln x times x squared, not x squared, but x squared x times 1 over x plus ln x squared. Whew. Okay, that's a lot of Chen-Lu for one day. Thank you guys for watching. Hopefully you enjoyed and learned all about the chain rule. I'll see you in the next video. Goodbye.